Tonight, step outside and look up. You'll see a couple thousand stars scattered across a black sky. It looks calm, ordinary, the way the night has always looked. But here's the thing, that black sky should not exist. By every rule we know, the space between those stars should not be dark. It should be on fire. The entire sky, from horizon to horizon, should be blazing brighter than the sun in every direction at once. So bright, it would burn your eyes out of your skull before you could even think to look away. That is what the math demands. And yet you look up and it's just dark, quiet, empty. That darkness is one of the deepest puzzles in all of science. It tormented the greatest minds for 300 years. And when we finally cracked it, the answer wasn't space is empty. The answer was so much stranger than that. The darkness itself is hiding where everything you have ever known came from. So let me show you why the night is dark. Because once you understand it, you will never look at an empty sky the same way again. Here's the thing that broke astronomers for centuries. Imagine you're standing in the middle of a forest, but a forest that goes on forever, in every direction, with no edge and no end. Trees scattered everywhere, near and far. Now look out through the trunks. Close to you, there are gaps you can see through. But the farther you look, the more trees stack up behind each other, quietly filling in those gaps. And if the forest truly never ends, then no matter which direction you look, your line of sight has to eventually land on a tree. There is no escaping it. Every single sight line ends on bark. Now swap the trees for stars. If the universe is infinite, and it's filled with stars going on forever, then the exact same thing has to happen when you look up. Pick any point in the night sky, any tiny dark gap between the stars, and follow that line outward far enough, and it must eventually land on the glowing surface of a star. Every direction, every point, the whole sky should be wall-to-wall starlight, with no gaps at all, glowing as bright as the surface of the sun everywhere you turn. The night should be blinding. There should be no night at all. So where did all that light go? Why is it dark up there? This question is old, and it has a name, Olbers' paradox. And for 300 years, nobody could truly answer it. The first answer people reach for is the obvious one. Maybe the light is out there, but something is blocking it. Space isn't perfectly empty after all. There's dust, cold clouds of gas, dark planets, and drifting rocks. Maybe all that distant starlight is real, but it's being soaked up, swallowed before it ever reaches your eyes, like fog eating a faraway streetlight. It's a good guess. It feels right, and it's wrong. Here's the problem. If you have that much starlight, a whole infinite sky's worth of it, pouring onto a cloud of dust day after day, century after century, forever, the dust doesn't just quietly absorb it. It heats up. Anything that soaks up energy for long enough gets hot, and anything hot enough starts to glow. Leave a metal poker in a fire, and the poker itself eventually glows red. Do that to the dust for long enough, and it would get so hot it would blaze just as brightly as the stars hiding behind it. It wouldn't cover the light. It would become another source of light. So blocking it doesn't work. You cannot hide an infinite sky. The darkness is real, which means something much deeper is going on. So, if the light isn't being blocked, there's only one other option left. Maybe the light was never there to begin with. And this is where the answer starts to get beautiful. That forest that goes on forever, filling every sightline with a tree. It only works if the forest has always been there. But what if the forest is young? What if it was planted recently and the trees far away simply haven't grown in yet? The universe is exactly like that. It is not infinitely old. It had a beginning, a specific moment, about 13.8 billion years ago when everything started, the Big Bang. And that one fact changes everything about the sky above you. Because light does not travel instantly. It's fast, but it takes time to cross space. So when you look out into the distance, you are also looking back into the past. The farther away something is, the longer its light has been traveling to reach you. And the older that light is by the time it finally arrives. Now, here's the catch. If the universe is only 13.8 billion years old, then light has only had 13.8 billion years to travel, not a moment longer. That gives you a hard edge, a wall you cannot see past. Any star so far away that its light would need more time than that to reach you, its light simply hasn't arrived yet. It's still on its way. The star might be out there right now, shining fiercely, but you cannot see it because there has not been enough time in the entire history of the universe for its light to cross the gap between you. So, the sky isn't full after all. Most of those sight lines don't end on a star. They end on emptiness, on parts of the universe whose light is still, in a sense, in the mail. Think of it like a letter sent from far away. It exists. It's already written and dropped in the mailbox, but until it physically lands on your doorstep, it might as well not exist for you at all. The night is dark, in large part, because the universe is young, and most of the letters simply haven't arrived yet. But the universe being young is only half the answer. There's a second thing happening, and it's even stranger. Space itself is not sitting still. It is expanding. Everything is drifting apart. Every galaxy pulling away from every other galaxy. The whole cosmos stretching larger with every passing second. And the farther away something is, the faster it is rushing away from us. Here's a simple way to picture it. Imagine drawing dots on a balloon with a marker, then blowing it up. The dots themselves don't move. Not one of them travels anywhere. But the distance between any two dots grows because the rubber underneath them is stretching. And the farther apart two dots start out, the more the distance between them increases over the same amount of inflating, simply because there's more rubber between them doing the stretching. The universe does the exact same thing to space itself, everything drifting apart not because it is moving, but because the space between it keeps growing. Now think about what that does to light. As a wave of light travels across space, and space itself stretches underneath it, the light gets pulled longer and longer. And when you stretch light out, it changes color. It slides from blue toward red, and then past red entirely, out of the range your eyes can see, into invisible infrared and beyond. We call this redshift. So even for the most distant objects whose light has actually managed to reach us, that light has been stretched so severely along the journey that your eyes can no longer register it. It arrives, but it arrives, invisible, faded into a part of the spectrum you were never built to see. So now we have two reasons the sky is dark. Some starlight hasn't had time to get here yet, and some of the light that did get here has been stretched out until it went dark to human eyes. The wall of fire is still out there. It's just been dimmed and delayed and shifted into colors we cannot see, which raises one last question. If the light of the early universe really is out there, stretched and faded and invisible, could we find it anyway? And here is the twist that turns the whole thing over. We were right the entire time. The sky is glowing in every direction. From wall to wall, from every point in the darkness, a light is pouring down onto you right now. You just can't catch it with your eyes, because it has been stretched too far. Go back to the very beginning. The early universe wasn't dark at all. Right after the Big Bang, everything was packed together, unimaginably hot, glowing white hot, like the inside of a star, and filling all of space in every direction. That is the wall of fire the paradox was looking for. It genuinely existed. But that was almost 14 billion years ago. And in all the time since, the universe has expanded so enormously that the fierce white glow of that fire has been stretched out and out and out, cooled and dimmed and shifted, all the way down from blinding light into a faint whisper of microwaves. It's still here. It still fills the entire sky in every direction, exactly as the paradox predicted. We even have a name for it. The cosmic microwave background, the afterglow of creation itself. And this is not just theory. You have met this light yourself. Old televisions, the kind that showed static between channels, that fuzzy snow, that hiss, a tiny fraction of it was this. The literal glow of the Big Bang arriving in your living room, 13 billion years late. Funny enough, that's actually how it was found. Back in the 60s, two engineers at Bell Labs were trying to calibrate an extremely sensitive antenna, and they couldn't get rid of a strange, steady hiss coming from every direction of the sky at once. They checked everything. They took the antenna apart and cleaned out years of accumulated pigeon droppings, convinced that had to be the culprit. The noise didn't go away. It was everywhere, all the time, with the exact same intensity no matter where they pointed the dish. It turned out they hadn't stumbled onto a broken piece of equipment. They had stumbled onto the afterglow of creation itself. The sky had been on fire the entire time. They just needed the right eyes to see it, and as it turned out, the right antenna would do too. So stand back and look at what the darkness is actually telling you. For 300 years, we treated the black night sky as empty, a nothing, a backdrop, the plain absence of anything interesting. It is the opposite. That darkness is the single loudest piece of evidence we have that the universe had a beginning. If the cosmos were infinitely old and infinitely full, the sky would blaze forever. It doesn't. It's dark. And that dark is only possible because there was a first moment, a birthday for everything, and because space has been stretching apart ever since. Every patch of black between the stars is a place where the light either hasn't arrived yet or has been pulled clean out of sight. The emptiness isn't empty. It's a record. The night sky is quietly holding up a sign that reads, "Everything you see had a start." So come back to where we began. You standing outside, looking up at an ordinary black sky. Only now you know what you're really looking at. That darkness isn't nothing. It's the edge of time. Look between the stars, into the deepest black you can find, and you are staring straight at the leftover light of the universe being born, stretched so thin, cooled so far, that it slips right past your eyes. The night is dark, not because space is empty, but because it is young, and because it is growing, and because the fire that should fill it has been carried away from you faster than it can ever arrive. Every gap up there is a story. Some of it is light still crossing the void toward you that your grandchildren's grandchildren might one day see. Some of it is starlight from suns that already burned out and died. And behind all of it, filling every single direction, is the faint, patient glow of the first moment of everything, the reason there is a sky to look up at in the first place. We spend our whole lives thinking of the dark as the absence of light. It isn't. It's the oldest light there is, wrapped around you on every side, too stretched and too ancient to shine. The night was never empty. It was the beginning, hiding in plain sight. And now, every time you look up into that black sky, you'll know exactly what it has been trying to tell you.